let's jump right in here and start filling in the blanks. If two sides of a triangle are different, then the larger angle is going to be opposite the larger side. And let me try and draw a picture of what's going to happen here. So, we're looking at two sides of a triangle. And in this particular triangle, let's just say, for argument's sake, that this side is 5 centimeters, this side is 6 centimeters, and this side is 7 centimeters. You are going to be asked in the test or on a quiz, which angle is bigger? So, let's consider the three angles in this triangle. Which one is the biggest angle? Well, you would probably agree that right here is the biggest side. And according to our new theorem, the biggest angle is going to be opposite the biggest side. So angle C is definitely the biggest. Alright, so if we list these from biggest to smallest, then what's going to be next? So the next biggest side is this one, which means the next biggest angle is going to be angle B. And then finally, the last remaining angle is angle A. Now, the next theorem is extremely similar. Now, if two angles of a triangle are different, then the larger side is opposite the larger angle. And again, it's very easy to demonstrate. So let's say that in a triangle I have a 50-degree angle here, and a 60-degree angle here, and a 70-degree angle here. Let's do the same thing. Let's go from biggest to smallest. Okay, so let's find the biggest angle. Well, clearly that's the biggest angle, isn't it? And according to this theory, the largest side is opposite the largest angle. So the side opposite the largest angle is here. So BA would be the largest side. What's the next largest side? Well, the next largest angle is 60, and opposite 60 is over here. So that's C. And then the final remaining side that we haven't talked about is BC. And so they are in order. Look how simple this question is. Now, the only thing you really need to pay attention to is this right here. They have asked you to list it from smallest to largest. In the previous two examples, I said put the biggest first. But here it's saying smallest to largest. So, let's find the smallest side. I think you'll agree that that right there, 17.2, is the smallest side. Well, that means the smallest angle is opposite. So angle F is the smallest. And now let's find the next smallest side. Well, the next smallest side is here. And opposite that is over here. So now it's angle H. And then finally we're left with angle G. And then let's go ahead and do number 2. Now this is we've got a little bit more work to do, because they haven't even told us what this angle right here is. So why don't we work that out quickly? If we do 180, because that's the total sum of the angles of the entire triangle, and we subtract 72 and we subtract 60, how much is that going to leave? Well, if you put that in your calculator or work it out by hand, either way, I don't care, you get 48 degrees remaining. So this angle right here is 48 degrees. Let's just pay attention again. Here they've said, can you list the sides from shortest to longest? So we do the same trick. We find the smallest angle and we go opposite right there. So the smallest side we can see is QP. And then the next smallest angle is going to be the 60. And opposite that is over there. So that's QR. And then the final side that we haven't talked about is that one, which is PQ. are. So they are nicely listed in order. So the next theorem, we need to fill in the blanks here. So the sum of any two lengths of a triangle is greater than the third side length. And this right here may confuse you guys a little bit, but let me try and explain what's really going on in this theorem. I want you to imagine for a second that I told you that there was such thing as a triangle that had one side length that was 1 centimeter, another that was 2 centimeters, and another one that was 10 centimeters. Well, if you imagine this right here, let's say that that's 10 centimeters long, all right? And let's now draw the 2 centimeter side. 2 centimeters will probably look something like that. Well, can you see a problem now? If I draw my final side, which has to be 1 centimeter, like this, you can see it doesn't reach to the other side. And the reason this doesn't work is because if you look at these two sides right here, 1 plus 2 is not greater than 10. That just doesn't work. So the only way we can do this, let me give you an example of one that does work, is if, let's say this was 5 centimeters, and this was 4 centimeters, and this right here was 7. Well, let's just check. What is 4 plus 5? Well, obviously it's 9, and that's greater than 7, so we're good. That works just fine. There's some examples below that I can show you that will make this a bit clearer. So 7, 10, and 19. And I would get into a habit of putting them in order each time you do this. Thankfully, these are already in order. But 7 plus 10 is how much? That's 17. Well, that's not greater than 19, so this does not work. You cannot have a triangle with those side lengths. Let's add up these two right here. Well, if we have 2.3 and 3.1, I don't even need a calculator here, I'm just going to say that is 5.4. That's greater than 4.6, so that works just fine. This is good.
Guys, I'm recording school videos and you are all screaming at the top of your lungs. I did say when I was going in here I was recording school videos.
Okay, number 3. We've got a little bit more work to do here. We need to plug in this 4 into each one of these, here, here, and here. And when we plug in 4 to n plus 6, we get 10. When we plug in 4 to here, we get 4 squared, 16 minus 1 is 15. And then when we plug 4 into here, we get 12. And just to be safe, I would put them in order. So I would go 10, 12, 15, and then I would add these two up. When you add those two up, is it going to be bigger than that? Well, you can see it's 22, and that is definitely bigger than 15. So yes, this works just fine. The thing to look out for, or how I'll try and trick you on a test, is probably I'll give you one that's equal. Like I'll say 3, 4, and 7. Can we have a triangle with 3, 4, and 7 as the side lengths? And some of you are going to say, oh look, 3 plus 4 equals 7, so that's good. And that's no good. It cannot be equal. The first two have to be greater than the third side. Okay, there's a super easy way to do this. Whenever you're given two sides like this and asked to find the range of values for the third, all you have to do is take those two values and start by adding them. So 8 plus 13 is 21, and then subtract them. 13 minus 8, and that gives you 5. And so this and this is your range. So it's between 5 and 21. And it cannot be equal to. So do not say that, because that would be wrong. You have to say it's greater than 5 and less than 21. Let's do the same with these two right here. Let's do 22 plus 17. And that's going to give you, what, 39? And then let's do 22 minus 17. And that's going to give you 5. So here my range of values is going to be 5, greater than 5, and then less than 39. Again, fill in the blanks. If two sides of one triangle are congruent to two sides of another triangle, and the included angles are not congruent, then the longer third side is across from the larger angles. Well, that sounds like a whole lot of confusion. Let me try and spell that out for you. Here we have two triangles. That side's the same as that side. That side's the same as that side. But the thing that they're saying is going to be different are the included angles, which means the angles that touch the two sides that they're talking about. So in this case, we've got angle A. Let's say angle A is 30 degrees. And then we've got angle D down here. Let's say angle D is 34 degrees. Well, what this theorem is saying is the larger side is going to be opposite the larger angle. So that side is opposite 30 degrees. That side is opposite 34 degrees, which means this side right here is going to be the bigger side because it's opposite the larger hinge angle. So take a second to fill in those blanks. And again, I will explain exactly what that's talking about. And the best way to do that is using example 1. So in example 1, they've asked you to compare BAC to DAC. And that is this angle here and this angle here. Which one is bigger? Well, look at the side that's opposite. Compare that one and compare that one. Which side is bigger? Well, it's clear that 7's bigger than 6, so that means that BAC is greater than angle DAC. And before we can compare these two, we need to know what this angle here is. Hopefully you can see that this is a linear pair, and so to get the other side we're going to do 180 minus 82, which is going to leave us with 98 on this side. So now let's compare this side to this side. And clearly 98 is the bigger angle, which means this side is going to be bigger. So GF is going to be greater than FE. I'm only going to have time to answer one of these questions, but let's compare this angle to this angle. Same thing. Look at the side opposite. Look at the side opposite. Clearly this 19 is bigger than 18. So that means that this angle right here is smaller, so 5k minus 12 must be less than or smaller than the 38 degrees. And then we're just going to solve that, and that's not too bad. We can just do 5k less than, add 12 to both sides, less than 50. So k is going to be less than 10. Now that's not the only thing we do. We also need to say that this angle right here, it has to be greater than 0, doesn't it? So we also say that 5k minus 12 is greater than 0. So that means we've got 5k greater than 12, or k is greater than 12 over 5. And when we put this piece of information together with this piece of information, we end up saying that k is less than 10 and is greater than 12 over 5. And now, because I'm limited to 15 minutes on these videos, I'm just going to show the work in a flash, and if you have your substitute teacher pause it, then you can take a second to try and follow through the work. So I've shown all my work, and hopefully you can just pause the video now, and if anyone doesn't understand, maybe someone smart in the class can help you out and just follow through what I've done there. But thanks for listening. Now go do your homework.